Hi, this is Ms. Smith, and today we're going to cover Chapter 1, Lesson 5 on graphing proportional relationships. Let's go ahead and go over our learning targets for today. We do have 3 of them, so please read along as I read them out loud. By the end of today's lesson, you will be able to do the following. Number 1, transfer information from a table to a graph. Number 2, explain how you know whether or not a relationship is proportional by looking at a graph. And last but not least, you will be able to interpret points on the graph. Now, if at this point this sounds a little confusing to you, don't worry, because yes, I am drawing you. By the end of this lesson, you will be a master. Or how about we just call you a ninja, because I kind of like that better. And if any point through this video presentation you're unsure about the concepts being discussed, please push pause, rewind, and watch the section that's not so clear to you and see if you can understand it a little bit better. If you still have questions, simply raise your hand and I will come and assist you. If you're at home, just go ahead and write down some questions and bring them to me when you see me in class. Alright, let's go ahead and begin. Because we are going to be doing a lot of graphing today, we need to make sure that we review the concept of the coordinate plane. As you remember, the coordinate plane looks just like this, and it's made up of 2 number lines that intersect or cross each other. The first number line is known as the x-axis. The second number line that I'm highlighting right here is known as the y-axis. Now, one last vocabulary word that's very important for today's lesson is this one right here. It's called the origin. And if you didn't know already, the origin is this point where the 2 number lines cross. Alright, now you might be wondering, Ms. Smith, why is the coordinate plane so important? Well, the coordinate plane is important because it allows you to locate a coordinate's position on the coordinate plane. So take point A for example. If we wanted to find the location of point A, we would write what we call an ordered pair. An ordered pair is made up of an x-coordinate and a y-coordinate. To find the coordinate's x-coordinate, you're going to go down from point A to the x-axis, and notice the x-coordinate here is 3. To find the y-coordinate, we're going to go back to point A and go left until we get to the y-axis. And as you can see, the y-coordinate for point A is 5. So point A is located at 3, 5 on the coordinate plane. Alright, we're going to go ahead and do 2 more. And I'm going to go ahead and pick a random spot. We'll call this Brandon's location, point B. And let's pretend that Brandon is stranded and lost in the desert. And we want to send the rescue crew Brandon's coordinate location so that the rescue crew could go and grab Brandon. Go ahead and figure out where Brandon is. I'll pause for a few seconds. Alright, hopefully that was enough time. Remember, Brandon's location is going to be described using an x-coordinate and a y-coordinate. And the x-coordinate, we're traveling down. The x-coordinate in this case is 5. The y-coordinate, we're traveling to the y-axis. And the y-coordinate in this situation is 7. Brandon is located at 5, 7. One last one, just to make sure. Go ahead and mentally find the coordinates of this location, point C. And once again, remember that each coordinate has an x. Each ordered pair has an x and a y coordinate. If you can't remember which one's first, remember x comes before y in the alphabet, so our x coordinate goes first. So let's look at point C. And we're already on the x-axis at 8. So our x-coordinate is 8. And if we go to the y-axis, our y-coordinate for point C is at 0. So the location of C is 8, 0 on the coordinate plane. Alright, that's all for review. If you need further review, simply type in plotting points into YouTube, and I am sure you will find plenty of videos on how to plot points on a coordinate plane. But now let's go ahead and get to the meat and potatoes of our lesson for today, which is how to identify proportional relationships by graphing. All right, go ahead and read with me as I read out loud. Another way to determine whether two quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. Now, we've already talked about what proportional means, and we've already talked about how to use a table to determine whether or not two quantities are proportional. So today we're going to look at a graph and determine whether or not the relationship is proportional. Now, if you read through this, the main thing that you should have gotten is that we know whether or not a relationship is proportional by looking at a graph if the line is straight and if the line goes through the origin. This is the information that you should come out of this slide knowing, and I'll write it down. Proportional. We know that a relationship is proportional on a graph if, number one, it is straight line, and number two, the line must pass through the origin. So we'll say goes through the origin. Now, what exactly does this look like? Well, in order for a line to be straight and go through the origin, it must start at the origin. So this would be an example of a proportional relationship. I'm going to go ahead and put my first point at the origin, and I'm going to go ahead and make this line straight. So I'm going to use a few more points to help me draw the straightest possible line, but you guys know my drawing skills aren't the best, and it's okay. Alright, this is as straight as my line's going to be. And as you can see, this relationship would be considered proportional because it is a straight line and it goes directly through the origin. Well, now that you know what a proportional relationship looks like when you graph it, what does a non-proportional relationship look like? Well, let's see. If proportional has to be straight and through the origin, what if we make a line that's not straight? So let's try that. If I go and start at the origin, but my line isn't straight, notice here when I connect these dots, although it goes to the origin, it is not straight. This would be considered a non-proportional relationship because, like we said, it is not a straight line. Alright, let's look at one more example of a non-proportional relationship. Remember that proportional relationships must pass through the origin. So what if our graph passed through this point here and was a straight line? Alright, so as you can see, even though our third line is a straight line, because it does not pass through the origin, this relationship is considered non-proportional. Alright, pause for a moment. Well, don't physically push pause, but think for a moment. Can you summarize this slide? Do you understand that proportional relationships are straight lines that go through the origin? If not, go ahead and re-watch this section. If you understand, alright, follow me. We're going on to the next slide. We're ready to tackle some problems. Alright, well, I'm sure the first thing you noticed when you looked at this slide is this cute little guy right here. He's part of our problem. This guy is known as the tree sloth. But don't let his looks fool you, because as he matures to an adult, do we even call fully grown sloths adults anyway? I don't know. But as it grows and matures, it doesn't look as cute. It looks kind of creepy. Anyway, let's focus on our problem. All right, I'm going to read it, and as I read, once again, please read along with me. The problem says that the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. All right, well, we're going to go ahead and start by highlighting this question. So I'm going to go ahead and highlight what the question is asking me to do. The question is asking me to determine whether or not the number of feet the sloth moves is proportional to the number of minutes it moves. All right, so going back to the concept of proportional, if quantities are proportional, they share the same unit rate. In this case, our unit rate would represent the number of feet the sloth moves. So I'm going to go ahead and write feet. And we want to know if that's proportional to the number of minutes. So I'm going to write minutes on the denominator. In other words, does this sloth travel the same number of feet every minute? All right, well, let's look at some other important information. How many feet is this sloth traveling per minute? Well, according to the text, this sloth is traveling 6 feet every single minute. So 6 feet each minute. All right, let's go ahead and represent this information in a table. And if you look at our table, in our first column, we have the number of minutes. In our second column on this table, we have the number of feet, or the amount of feet moved. So if we know that this sloth travels 6 feet every minute, we know that after the first minute, the sloth will have traveled a total of 6 feet. All right, well, what about after 2 minutes? Well, after 2 minutes, if this sloth is traveling 6 feet every minute, after 2 minutes, the sloth will have traveled a total of 12 minutes. 6 feet the first minute, an additional 6 feet for the second minute. So after 2 minutes, we will have traveled, or he will have traveled 12 feet. All right, after 3 minutes, the sloth would have traveled 18 feet. Well, we want to know whether or not this relationship is proportional. Now, we could look to see if the unit rates were the same, right? If 6 divided by 1 is 6 feet per minute, if 12 divided by 2 would also be 6 feet a minute, and if 18 divided by 3 would be 6 feet per minute, but we're not going to do that. We're going to go ahead and put this information on our coordinate plane. Now, it's really important that as you put the information on the coordinate plane, you identify what information goes on the x-axis and what information goes on your y-axis. So I'm going to tell you. If you go back here to our unit rate, the information on the y-axis would be feet, and the information on your x-axis is going to be minutes. So on my y-axis, I'm going to label the information on my y-axis feet. All right, bear with me. This is the first time I've created lessons on this iPad, and it should not be feet, it should be feet, right? And on our x-axis, we're going to go ahead and put minutes. So these numbers down here represent minutes, and these numbers here are going to represent feet. So let's go ahead and write these coordinates as ordered pairs. The first one is 1, 6, the second one is 2, 12, and the third one is 3, 18. Okay, but what does this mean? This means in 1 minute, we move 6 feet. So let's go to 1 minute and go to 6 feet. We're going to put that point right here. Alright, so The second one would be after 2 minutes, we moved 12 feet. So we're going to go to 2 minutes and go all the way up to 12. Picture where that would be right there. And after 3 minutes, we moved 18 feet. So 3, go all the way up to 18, and there we go there. Now, we can't tell by looking at this, but if we connect our line, or our dots rather, we will see that this line actually does go straight through the origin. So to answer the question, is this relationship proportional? We would have to say yes. This relationship is proportional. Why? Because it's a straight line. Because the line is straight. And it goes to the origin. Hopefully, you see how this information is connected to what we just talked about. Alright, let's look at this information in a very clear way. So this is the answer from the book, and we want to make sure that we put our answer in a complete sentence. Please read it. It says that the line passes through the origin and is a straight line, so the number of feet traveled is proportional to the number of minutes. Okay. Please make sure as you write your answers that you write them in complete sentences. And please make sure that you understand that when you graph your relationship, if the line is straight and goes right through this point, the origin, then it is proportional. Alright, are you guys ready to do number 2 or the second problem on your own? Let's see if you understood what we just went over. Go ahead and pause this, do the problem on your own, and come back to review the solution. Alright, you should be back. You should have done this on your own. If you didn't, please push pause and push play when you are finished. Alright, here we go. I'm going to read the question. And according to the question, James earns $5 an hour babysitting. Determine whether or not the amount of money James earns babysitting is proportional. So we want to know whether the amount of money earned is proportional to the number of hours he babysits. Okay. So I'm going to go ahead and start by writing my unit rate, and I'm going to write it up here. Okay. And we want to know if the amount he earned is proportional to, so whether or not the amount of money that he earns is proportional to the number of hours. So I'm going to put earned on top and hours on the bottom. Earned came first when we write this. Hours came second. Okay, what this unit rate would tell me is the amount that James earns per hour. And according to our information, James earns $5 every hour. All right. Well, we can go ahead and put this information into a table. So if we do that, after the first hour, James will have earned $5. Well, if he earns $5 every hour, if he works a total of 2 hours, he will have earned $10. And if he works a total of 3 hours, he will earn 5 more. So now that brings his total amount earned to $15. We want to know whether or not this relationship is proportional. Does James make the same amount of money each hour? So we said that we would go ahead and graph this. I'm going to go ahead and first write these as ordered pairs. We have 1, 5. We have 2, 10. And we have 3, 15. Remember, 1, 5. 1 represents the number of hours worked, and 5 represents he earns $5. Okay? You can use that same pattern to determine what the ordered pairs represent for this one and for this one. So at 2 hours, he earns $10. For 3 hours of work, he earns 15. All right, we're going to go ahead and graph this. Okay, remember when they graphed this and created their coordinate plane, they put the time on your x-axis and the amount that they earned, they put that on the y-axis. If you go over here, remember the y-axis, that's the information for the y, that's the information for your x. Okay, so notice y would be the amount of money they earned, x would be the number of hours. So that's what you see here. Y is the amount of money they earned, x represented the number of hours. So let's go ahead and plot 1, 5. So at the first hour, we're going to go all the way up to 5. 5 is right here between 4 and 6. So the first hour you earned $5. For the second hour, you're going to go up to 10. For the third hour, so we're going to go right here to the third hour, and we're going to go up to $15. Now 15 is between 14 and 16, so there it is right there. Alright, you're going to do your best to draw a straight line. It must go through the origin. So let's see. Draw our line, line 999. And yes, indeed, it does go through the origin right here. So, is this line proportional? The answer is yes. This line is proportional. It's a straight line that goes through the origin, which means, yes, James does make the same amount of money every single hour. And this is the answer from the book. It says that the amount of money James earns is proportional to the number of hours he babysits. The graph is a straight line through the origin. Alright, if you have a question on this one, if you didn't understand something, once again, go back, review this question again, and raise your hand if you need some assistance. Alright, let's look at our next example. Okay, in our next example, the cost of renting video games from Games Inc. is shown in the table. So this table right here shows you how much it costs to rent games from this company. We want to determine whether or not the cost is proportional to the number of games rented. So remember, when we do that, we want to know if the cost is proportional to the number of games. So what does this mean? We want to know if it costs the same amount per game. So we're going to go ahead and graph this. Okay. Let's go ahead and bring up our coordinate plane. Alright, we're going to put our information here. Since on the unit rate, or on the rate, cost is on top, remember this one would be your y. And this one right here is going to be your x. So cost is your y. You get your information on your y-axis. And the number of games is the information on your x-axis. Alright, so let's go ahead and write the ordered pairs. Okay, so the ordered pairs, we have 1, 3. Right, x, y. So 1 represents one game, y represents the cost, so $3. So one game costs $3. 2 games cost $5. 3 games cost $7. And 4 games cost $9. So let's go ahead and graph that. One game costs $3. That's this point right here. 2 games cost $5. So 2 games cost $5. That's this point right here. 3 games cost $7. Right, $7 for 3 games. And 4 games cost $9. Okay. Remember, it's proportional only if it's a straight line going through the origin. So we'll go ahead and connect the dots. And this line does not go through the origin. Even though it's a straight line, it does not go through the origin. So we can conclude that this line is not proportional. Let's go ahead and look at the explanation. The explanation says the line does not pass through the origin, so the cost of the video games is not proportional to the number of games rented, which means each game does not cost the same amount. The cost per game is not the same. This line is not proportional. If you have a question, rewatch this section and then raise your hand. Let's move on to the next question. Okay, you're going to push pause on this and only push play when you've completed this on your own to watch the solution. I'm going to stop now. All right, you should be back. You should have done this on your own. I will go ahead and read it. In this problem, it says that the table shows the number of calories an athlete burned per minute of exercise. So I'm going to write that down in a second. I'm going to write that down in a second. It says, determine whether the number of calories burned, so what's going to go on top? The number of calories burned is proportional to the number of minutes spent exercising. So it's asking us, do we burn the same amount of calories every minute? Well, if we graph this, the first one's going to be y. The information on the top is your y-axis. The second piece of information is your x-axis. So notice on your x-axis, we have time in minutes, just like we had here. And on our y-axis, we had calories burned. And we knew that because on top of our rate, we had calories burned. All right, so we're going to go ahead and graph this. So we have the point 0, 0, which means at 0 minutes, we have 0 calories burned. We have the point 1, 4, which means at 1 minute, we burn 4 calories. We have the point 2, 8, which means at 2 minutes, we burn 8 calories. And we have the point 3, 13, which means at 3 minutes, we burn 13 calories. So we're going to graph that. So 0, 0. Okay, it starts at the origin. Maybe it's proportional. Let's do 1, 4. So 1, 4, that's here. 2, 8 is here. And 3, 13. It's looking good until we get to 3, 13. Now 13 is between 12 and 14. Okay. Now notice, this is straight all the way until we get here. This is not a straight line. Okay. It might look straight. Okay. It might look straight, but this is not a straight line. If it was, notice here, we're going to go up 2 and over 1. Up 2 and over 1. If we go up 2 and over 1, our point should be here, but it's not. It's right here. This is not proportional. Not proportional. Because, I'll write the word because. Line is not straight, even though it goes to the origin. O-R-I-G-I-N. Okay, it's not straight even though it goes through the origin. So this is not proportional or non-proportional. Now, as you're going through, if you have any questions at all, jot those down. That way you can ask. All right? This was the book example. As you can see, they did theirs a little bit more clearly than I did. And you can see that this line is not straight. So even though this line goes through the origin, because it's not straight, it is not proportional. So as you read, it's not proportional. The line is not a straight line through the origin. It's straight. I'm sorry, it's through the origin, but it's not straight. All right, let's do another one. All right, I want you to just look at this, and I want you to answer this. I'll give you a couple seconds after I read the question. Just do this mentally. Number 3, it says, which batting cage represents a proportional relationship between the number of pitches thrown and the cost? Which one is proportional between the number of pitches thrown and the cost? Explain. All right, giving you a couple seconds. Which one's proportional? Is it softball plus? Okay, this line represents softball plus. And this one right here represents the fun center. Which one of these is proportional? I hope you said that fun center is proportional. Notice that fun center is a straight line that goes through the origin. Okay, so this is the explanation. The graph for softball plus is a straight line. So this one right here, it's a straight line, but it is not passed through the origin. So the relationship is not proportional. Okay, let's look at fun center. This is fun center right here. Fun center is a straight line through the origin. So the relationship between the number of pitches thrown and the cost is proportional. So this one was proportional because it's a straight line through the origin. And what does proportional mean? It means that since we're talking about the relationship between the number of pitches and the cost, okay, this unit rate would tell, well, we're going to put the y first, right? The information on the y-axis is cost, and the information on the x-axis is pitches. So we want to know, is the cost per pitch the same? And yes, to throw each baseball, okay, it costs the same amount of money. So if you're going to the batting cage, it's going to give you the same number of balls to swing at. It's going to cost the same amount for each ball that you're swinging at. All right. Hopefully you understood that one. Let's move on to our last one. The number of students is proportional. Notice this relationship is proportional. The number of students is proportional to the number of teachers. So that means that each teacher has the same number of students. We know this because this is a straight line that goes through the origin. Part A is asking us to find and interpret the unit rate. Part B is asking us to explain what these points represent. So go ahead and push pause, do this problem on your own. All right, you should be back now. We'll go ahead and go over part A. The unit rate. The unit rate, to find the unit rate, it's always the information on the y-axis divided by the information on the x-axis. In this case, on the y-axis, we have the number of students. And on the x-axis, we have the number of teachers. So number of students, number of teachers. Okay, we want to know, what is the unit rate? How many students per teacher? Well, let's look at this point right here. Okay, this point right here is 125. Well, 1 represents the number of teachers. So I'm going to write 1 for teacher. Over here, this is the number of students. So if I go over, this is 25. Notice, This is 25 because from here to here is 50, so halfway is 25. So this is 25 students. Plus it also tells you 25. So what's the unit rate? Well, 25 students per teacher. Okay. Remember, the unit rate tells you how much for 1. So you just have to go to the x-axis and go to 1 and go up to the graph, and that will tell you. Okay, or you can just write it out. We have 25 students divided by 1 teacher, so the unit rate is 25 students per teacher. Okay, we could have picked another point. We could have picked this point right here. And this point right here, if we go down, remember it's y over x. So if we go down, our x coordinate is 4. If we go over, our y coordinate is 100. So if we divide that, this is students, and this is teachers. Okay, can't read that. Teachers. Okay, if we divide, 100 divided by 4 is going to be 25 students per teacher. Okay, so our unit rate is 25 students per teacher. Okay, explain what these points mean. 0, 0, 1, 25, and 4, 100. Okay, remember, every ordered pair has an x coordinate and a y. So x represented teachers. So this means 0 teachers, 0 students. Okay, that means if there's 0 teachers, there aren't any students. Remember we said there's 25 students per teacher. Okay, this one, x is 1, so 1 represented x, x is teacher, so 1 teacher, 25 students. Okay, that was y. X here is 4, so 4 x coordinate is teachers. Y coordinate is 100. Remember, the y coordinate represents students. 100 students. Okay, hopefully this PowerPoint presentation was sufficient. You should be able to answer the end of the lesson reflection question, which is in your own words, explain how you know if rates are proportional by graphing. Make sure to include a graph. Actually, be sure to include a couple of graphs. And please give me your feedback. Was this helpful? Did you understand? All right, check Google Classroom for your next assignment, and I am signing off.